Okay, so today we are going to discuss about the network security in application layer. So I think this is our last topic for the computer networks. We have discussed the application layer. In first part, we have discussed the various protocols or various services provided by the application layer, like mail services. We have domain name services. We have World Wide Web. We have HTTP, Hypertext Transfer Protocol. You are going to daily use the HTTP. These are the pages where we can create the forms. We will see the images and all other stuff, and you are aware about the FTP, file transfer protocol, in which we are able to access or send the files to the remote locations, right? And you have already used the TeamViewer remote login. This is also in services for the application layer. Now the next part is network security, and here the various aspects of the security are privacy, authentication, integrity, non-repudiation. Now, how we can evaluate these terms? Privacy means what? The data that is generated by the source or that is generated by a node, that is generated by a user, should remain the private, right? Nobody is able to access this data. Let's say A wants to communicate with B, then this data is private with the A and B. No other third party like C, D or E is able to access the data. The privacy of data should be maintained at the highest level. Authentication, that means that the person who are generating the data is authenticate person. Let's say there's communication between A and D. Now the D has to verify that the data is coming from the verified user A. There's no any malicious user or any bogus user in between who will generate the data that is received by the destination. Integrity means the data that is going to travel through the communication medium, transmission medium, should remain intact. No intermediate user or any attacker is able to access the data, and they are not able to modify the data. Non-repudiation means that is some sorts of agreement. Let's say A has sent the data to D. Now A can't deny that it has generated the data. That means if A sends the data, it has to take authenticity of the data, right? This is some sort of agreement. The data is coming from the A, right? And after the generation of data, A can't deny for the same. So repeat, we have the privacy, authentication, integrity and non-repudiation. These are the four aspects. Privacy means the data should remain the private. It is not accessed by any other user. The privacy and security of data should maintain at all cost. Authentication, the data is generated by the authorized user. There is not any kind of bogus user. Integrity, the data should remain intact from any viruses or any in-between attack. No reputation, some sort of agreement. If you generate the data, you have to take responsibility of it. You can't deny for this. Now, these all aspects can be achieved with the help of some sort of key management. Key is some sort of like we have the lock, and lock is opened by the key, right? Encryption is what? Encryption is a technique in which plain text is converted into the ciphertext. Let's say we have the data A, B, C, D. He is a good boy. English, that is something what we can call plain text. Now when encryption technique is applied, the he is a good boy is converted to some other format that is not understandable by the common user. This is something what we can call the encryption. So encryption is a technique in which the plain text is converted into the ciphertext. A normal plain text that is normally understood by the user, but ciphertext is not understandable by the normal user. We need some sort of algorithm or some sort of techniques to decrypt the ciphertext into the plain text. I hope you understand. So Encryption is a technique in which normal plain text is converted into the ciphertext. Then decryption works in the reverse manner. If source encrypt the data, then decryption is performed at the destination end. There are a number of algorithms that are available for encryption and decryption. Now, to perform the encryption and decryption, we need some sort of key. That key is maybe common in A and B, maybe this key is not common in A and B. There are a number of mechanisms for that. Like if we have the lock, we need the key to open the lock. So this key is some code that is shared by the source and destination. That code may be the same, or maybe this is different for source and different for the destination. Based on that, we have different types of technique. In case of secret key encryption, the same key is shared between the source and destination, and this is only shared by the particular source and particular destination. The person who has the key is able to decrypt the data, otherwise he is not able to decrypt the data, right? So this is how they maintain the integrity of the data, right? Let's say in between the network, if some third person is able to access the data, he is not able to understand it because he does not have the key that is only with the destination B, right? You understand? Then we have the public key encryption decryption. Now let's say again we have the parties A and B, and there are two different keys. One is private and one is public. Now any source who wants to send the data is going to encrypt the data with the help of public key, right? Let's say A wants to send the data to B, then it will use the public key of B to encrypt the data. Now if this data reaches to B has their private key. He used this private key to decrypt the ciphertext into the plain text. Let's say there's another user C, there's another user D. Now he wants to send data to the C, then he will use the public key of C to encrypt the data. Then C has their own private key. With the help of C private key is able to decrypt the data. So what is difference between these two techniques? In A and B, they will share the common secret key. To encrypt and decrypt. And in case of public key decryption, he will use the public key to encrypt, private key to decrypt. Now these two slides will make basics for the next coming techniques. These are the two basic techniques that need to remember, that secret key encryption and public key encryption. Then let's say we have the combination. What combination will say? That secret key encryption, encrypted secret key decryption. Then B has its own private and B has its own public. Now how this will perform? On upper part, in the yellow, you will use the technique of private public encryption. Lower part, where encryption and decryption in the sky blue color, you will use the secret key to encrypt and decrypt. So this is the two basic technique that we are going to use for encryption and decryption. Now signing the whole document. This is some sort what we can call, the name of this topic is digital signature. In your syllabus it is given in form of digital signature. It is exactly reverse to the this public key decryption. In that case, encryption is performed with the help of public key and decryption with the help of private key. But what you can see in that case, A has its own private key, and this will use the private key to encrypt the data, right? Now let's say this data is for B, this data is for C or D. Whosoever wants this data, he will use the A's public key to decrypt it. So what is signature? Signature means what? Verification, that I'll use my signature to verify that this document belongs to me. In that case, this is signature by the source. In our example, this is signature by the A, who will generate the data, who verify that this data is generated by me. Now, whosoever wants this data, whosoever will use this data, whosoever decrypt this data, he will need his public key to decrypt the data. So I hope you understand. We have the three basic. One is the secret key encryption, another one public key encryption, and third is the signing the whole document, or what we can say digital signature. Now one is the signature in the whole document, another we have the signature in the some part, digest, we will call the digest. So we have the whole message. And hash function is a mathematical model or mathematical technique in which we will convert the whole message into the some small length message digest, or something what we can call that is generated by the hash function, right? And that is of fixed length. Whatever the message length is, it is of fixed length. It will convert the whole message into the small part with the help of hash function. That technique is called the hashing technique. And now on one part we will sign the whole document. In that case, the fixed length digest is signed by the user. Now what you will see in the figure, A will generate its message, and on lower part we have the hash function. It will apply the hash function, it will generate the digest. Then is private key is used to encrypt the digest. Then we have the signed digest, and this signed digest is added with the message plus signed digest. You understand this term? Let's say we have the A message, hash function is applied, hash value is generated, hash value is called digest. Hash value is encrypted with the help of A's private key, and then signed digest is added with the original message. Now it is ready to transfer. Now what B will do, it will see the data from A. We have the message plus hashed digest. Now again same hash function is applied to the message, obviously, right? We have the message here, we have the message, hash function is applied, and what it will generate, it will generate the digest. In that case it will apply the hash function, what it will require, it will generate the digest, and on red part it will use the A's public key and decrypt it. It will also generate the digest. Then we need to compare this digest. This technique is called the digital signature. So digital signature will cover maybe all aspect of security. It is going to check integrity. When we compare the digest, we are able to know that we receive the message without any error, right? And this message is for me only, right? So I think you understand this term, right? So we have the different protocols that are working on the PGP stands for pretty good protocol, right? Again, it is the version of the this digital signature that works on the email hash function is applied, digest, encryption, signed digest, email plus digest. Here we use the term message, here we use the term email. Rest is same. Now digital signature, one part is digital signature, another part is privacy. Now how privacy is concerned, then we encrypt the whole message with the help of one-time secret key. Encrypt, B is public, it will encrypt the whole scenario. Now encrypted secret key plus message plus digest. Earlier we have the message plus digest, then we apply the privacy, that we first technique, this encryption, this one, we apply this technique encryption and decryption to forward to digital signature plus privacy is attained with the help of public private encryption. Now they will generate message plus digest, then they have the secret key, right? Now what will happen at the destination end? I hope you understand at the source end. Digital signature plus privacy, email plus signed digest, then it encrypt one time secret key, it will also encrypt. So we have the encrypted secret key plus message plus digest. Now we will receive the encrypted secret key plus message plus digest. Then what will happen? It will decrypt with the help of B's private. In that case, we will use B's public key or the earlier concept. Public key is used to encrypt the data, private key to decrypt the data. Now it will use the B's private key on upper side, and what it is going to generate? It will generate the one-time secret key. Now this secret key is used to decrypt the encrypted message plus digest. It will decrypt what we will need, email plus hash value. Now this hash function, the other part is hash function is decrypted, what we require, digest. Then email hash function is applied, what we require, digest. Then compare the digest, everything is fine, then it will accepted by the receiver. So this is pretty good protocol how it works. First we have the email. On email we will apply the hash function. What we will generate, digest. This digest is encrypted with the help of A's private. Then we have the signed digest. Signed digest is added with the email, right? Now here we use the A's private key to encrypt. Here we use the B's public key, the earlier concept. Now that's it, this data is for B. We have the one-time secret key. That secret key is encrypted. That secret key is encrypted, and this image plus signed digest is also encrypted, right? Now encrypted secret key, message and digest. Now on that case, first we decrypt the secret key, then decrypted secret key is used to decrypt the email and digest. The email and digest, email is applied hash function, it will generate the digest. Digest is decrypted, it will generate the digest. Then this is compared, everything is fine, it will receive the data. Now further we have discussed the privacy, we have discussed that digital signature, integrity of data will use the digital signature. Then we have the authentication. Authentication means the data that is generated by an authenticated user. Now you will see a diagram, we have the A and B, right? And we will share the secret key. How this authentication is performed? They will share the secret key. A will send the data, I am A, B reply with the R is a data, right? Now this R is encrypted ER, some encrypted value is generated. Now this encrypted value is sent by the A to B. Now B has also the secret key, it will decrypt it. Now if it receives the R, that means the data earlier generated by B, if it decrypt and match R with the original R, based on that it will accept or deny. This is how authentication is made, that it is communicating to the authorized person or not. You understand this, that we have the first A will told to B that I am A, you want to communicate, okay. B reply, I am fine, he sent the data R. Now they have the secret key shared between A and B. Now he performed its encryption, and encrypted data ER is sent to the B. B will decrypt with the help of secret key, and it compare this R with the original R. If both are same, accept, otherwise deny it. Now this is secret key. Otherwise we have the other concept, that is private public key, right? Again process remains the same. He told I am A, he sent R. Now A will encrypt the R with the help of its private key, send the ER to the B. B will decrypt the R with A's public key. Now it compare R with the original R. Based on that it will accept or deny. This is how this authorization is made. So what is the basic scenario, that we have these three basic slides, and these are the theoretical terms: privacy, authentication, integrity, non-repetition. We will maintain the privacy, obviously we will remain the Privacy means encryption decryption technique used to maintain the privacy. Authentication, we have discussed, integrated digital signature. No reputation, again, that if A sends the data to B, A will not deny it later on. I'm also going to share the notes for the same on Google Classroom, and I am also going to share this video lecture. And if still anyone has any doubt, he can call me anytime. Okay, so A performance encryption, network decryption, public key combination, and we have the concept of digital signature. So that's all about the today's lecture. I hope you understand this.